This one, find the slope and the y-intercept. Well, if it's in slope-intercept form, it's going to be very easy to identify. But this one's not in slope-intercept form. It's not in y=4 form. So guess what we can do? Let's put it in slope-intercept form. So 8x, I'm just going to come over here and rewrite my function. And I've got to move my x term.
So negative 8 over to 19?
Negative 8x. I'm moving the whole term, not just the 8. And I like my x term to come first, so I'm just going to put negative 8x plus 19. And then I'm going to divide everything by negative 7. It's going to give me y. Negative 8 over negative 7. A negative over a negative is a positive, so 8/7 x. And then 19 over negative 7, you can just leave it negative 19/7. If 7 went in evenly, then I'd worry about it. And make sure your fractions are simplified, and they are. So y equals 8/7 x minus 19/7. So now when the problem says the slope is, well, the slope equals 8/7. Remember, that's your slope. And the y-intercept, or your b, is negative 19/7. So when they say the y-intercept is, and they already have the 0 flooded in like that, because remember your y-intercept is a location, it would just be 0, comma, negative 19/7. So those are your two answers. All right. This one's kind of blurry, but I think you can definitely still read it on your paper, probably a little bit easier than up here. This is number 7. Okay. And it says solve by the substitution method. So substitution method, and it's already set up perfectly for substitution, which we kind of reviewed on Monday. Remember, to use substitution method, one of our variables has to be isolated, meaning by itself. And my second one is x equals. So since x equals all of this, 19 minus 3y, wherever I see an x in my other equation, I can plug it in for that. That's going to give me a brand new equation with just a single variable. So my brand new equation is going to be 9. Now instead of x, I'm going to put 19 minus 3y. And then plus 4y equals 10. So now I have an equation with just y's in it. If there's just one variable, we can solve for it. So I'm definitely going to have to do distributive property first. I got to get rid of my parentheses. 9 times 19 is 171. 9 times negative 3, so that's going to be negative 27y plus 4y equals 10. So all I'm doing now is I'm just going through the equation solving process. And you want to simplify as much as you can before you start moving things. So I've done the distributive, and now I can combine like terms. I have y's. So that's going to leave me 171, and I have minus 27y plus 4y. So that's a negative 23y equals 10. Now I can start solving. So I'm going to move the 171. And that's going to give me negative 23y equals a negative 161. And then now I just have to divide by negative 23. And hopefully it goes in evenly. It'd be great if it went in evenly anyway. It's a negative over a negative, so I know it's a positive. What's 161 divided by 23? 7. Yay, okay. So we have, and notice it says type an ordered pair. Well, I have the y part. So it's like I have the second half of my answer, but I still need the x coordinate that goes with this y. So now I can just take one of my original equations, and I'm going to take the one that says x equals, because that would make the most sense because I'm looking for x. So x is going to equal 19 minus 3 times, well, I got 7 for y. So 19 minus 21, so it looks like x equals -2. So my answer is -2, 7. So this one is exactly what I was just saying, where if we're going to use substitution method, we need to isolate a variable. But I don't have a variable isolated right now. But I have 4 choices. I have the x that's attached to the -3. I can isolate that if I wanted to. I can isolate that 1y, or the 9x, or the 18y. I can pick any of those to isolate. Now, which one's going to be the easiest to isolate? Meaning get by itself. The y on top. Because it's already kind of isolated, all we have to do is just move that minus. So yeah, if I take this equation and I rewrite it to be y equals, then I've isolated a variable. So I would just have to add 3x to both sides to make that happen. So that's going to give me 21 plus 3x. So now that I have an isolated variable and it's 21 plus 3x, wherever I see a y in my other equation, I can plug that in. You have to make sure that you plug into the other equation. Don't plug it back into itself. I know that sounds funny, but it's a very common mistake. So now our new equation is going to be 9x plus 18. Now instead of y, we're going to replace it with 21 plus 3x equals 63. Now I can start simplifying and then eventually solving. So I'm going to have to distribute. 18 times 21 is, somebody check it, 378. Is that right? Okay. And then 18 times 3x would be 54x equals 63. So I've distributed. Now I can combine like terms because I have 9x and 54x, which would be 63x. Now that I have everything simplified as much as I can, now I can start moving things around. So I'm going to have to get all of my numbers on the right side. So I'm going to subtract 378 from both sides. And that's going to give me 63x over here. And 63 minus 378, negative 315. Divide by 63. And -5? Okay, so x equals -5. Now remember again, that's only half of our answer. That's the x coordinate. So now I have to go in and find my y. Now you can pick either one of your originals. It doesn't matter which one. I would probably just pick the top one because the numbers are smaller. That's really my only reason for picking it. So if I go -3, now instead of x, I'm going to replace it with -5 plus y equals 21. So that's a positive 15 plus y. Subtract 15 from both sides. And y equals 6. So it looks like our final answer is -5, 6.